Hey everybody, I'm Mark. Welcome back into my studio. It's been a little while. I was away on a nice little summer vacation for a few weeks, and now I'm back in the studio, and actually some things arrived and some projects have piled up while I was gone. So we're going to start to tackle those today. And because I only like to have one of my 3D printers back there out of commission at a time, I'm going to do what I think is probably the simplest of the projects first. So we'll tackle that one in today's video. And then coming up, I actually have the conversion kit to change my Prusa Mark IV's into a Core 1. So that'll be coming up in a future video, probably not too long from now, because I really am looking forward to that. But the thing that I want to look at today is this little box here, which has a brand new extruder in it. This came while I was away, and I guess I have to do that YouTuber thing for the very first time ever on this channel. This was sent to me for free by BIQU. It's the Nebula. It's their new extruder. They didn't ask for me to even make a video about it, and they're not like sponsoring this video or anything like that. They just reached out and asked if I wanted to try this out. I told them the project I had in mind for it, so they kind of know that I was planning to make a video and what it's going to be about, but they're not going to see this video or anything like that. And I'm not really treating this as like a review of this Nebula extruder. I'm just going to use it in the project. I'll tell you what I think of it as we go along. But other than that, it's not meant to be like a review. It's not a sponsored thing. It's just, for me, the very first time that a company's reached out and offered to send me something that I was actually interested in trying out. So here we are. So I'm going to open the Nebula here, and we'll take a look and see what's inside the box. And then we're going to put it into my Voron V0 printer, which I have sitting here on the desk. I've got a Dragon Burner tool head in this thing. Let me tip it so you can see that thing. And it's got a LDO orbiter extruder on it right now. So we're going to take that extruder off and replace it with this new Nebula. At least that is the plan, and we'll see how it goes. So in the box here, we don't have a whole lot. We've got the extruder itself, of course, and it's nice and small. I kind of like that it's just a very squarish kind of design, and the filament path goes right down the middle of it. So that's kind of cool. And then I think other than that, we've just got a box of cables. They gave me a sticker, so that's cool. And yeah, that's all that's in this box. So these cables are, let's see what we've got here. This looks like just to be an extension cable for the motor. So it's got four pin connection there. So if this is not long enough, if you don't have a tool head PCB that you're just reaching back to, and you've got to go back, maybe back through an umbilical or something like that, they have this there for you. And then I believe the rest of the cables are just for the additional functions that this thing has. So maybe we'll talk about those now. There is a 5-pin connector up at the top of the extruder here. And those 5 pins handle power and ground, I believe, and then a single pin each for the filament sensor that's built into this thing. The button, there's a little button switch right here that clicks, that you can, assign maybe a G-code macro to or something like that. I think probably the idea is to use it for loading and unloading of filament, which is what I'm going to use it for. And then also they have 2 LEDs. They're right here kind of in these little triangular openings in the front here. I don't really care that much about the LEDs. I have LEDs elsewhere on my printer already, and so I'll probably hook them up to see them working, but I'm not really sure what I'm going to use them for other than that. Anyway, all of that said, there is it looks like a 5-pin cable that connects into here that then breaks that out into 4 and 1, which is the middle pin, it looks like, of a 3-pin connector. I imagine that this cable is made for some toolhead PCB that BIQU provides that has those types of connections already needed, or already set for what you'd need. The other version of this cable, which is really long, and again, it's probably meant to go back through an umbilical to your board that's controlling your printer, has the 5-pin connector on this end, and then it breaks it out into 3 different 3-pin connections. So the one has the 2 power and ground wires along with a signal wire for I don't know which one of the 3 things, and then the other 2 are just a single wire on a 3-pin connection. So whether or not I'm going to use this cable, or I might just make my own for the toolhead PCB that I have on my Voron V0 already, we'll have to see as we go along. But anyway, it's nice that they provided you those cables. And then what else is in the box? It looks like just a couple of tools. So yeah, a flathead screwdriver, an Allen key, and then a little length of PTFE tubing so that you can run this down to your hot end. As far as the extruder itself, it's fairly lightweight. I wouldn't say it's the most lightweight extruder that I've ever held in my hands, but it is nice and compact. The casing is plastic, not metal, so that probably helps keep the weight down. It feels nice and sturdy and good. You can kind of see the two side gears here. This has a planetary gearbox back in here, and then it's driving these two drive gears that mesh together. I think there's a magnetic front panel here, so we can pull that off, yeah, and kind of see what's inside here. So you can see the filament path goes straight down through the middle, and there is no way for me to manually turn these things. There is so much torque on this planetary gearbox that, yeah, there's no chance of me turning these gears by hand. Which is probably good. It's going to have a lot of torque, it looks like, from just the way the design works. And then right here, I think behind where this circular little opening is in here is where the filament sensor lives, right? So the filament sensor is right above the drive gears that grab on to the filament there. On the underside here, this is one question that I have that I'm going to have to look into. There are 4 mounting screw holes. And then, of course, the filament path right here. And that's kind of a weird arrangement. I'm not quite sure how I'm going to mount that yet onto my Dragon Burner tool head. Just as a bit of comparison here, this is the mounting plate for the orbiter extruder that I already have in there. And it's got just these 2 holes here and the filament path. This is a spare piece that I had that didn't print very well. You can see it's a bit warped. So I had saved it, but I'm not using it. But if I hold this here, and I try to line the filament path up right about like that, you can see these back 2 mounting holes are like not going to even overlap where this plastic goes. So to be able to mount this on the Dragon Burner, the way that it's arranged and oriented and how you have access to these holes is going to be a bit weird. I might end up just designing a plate like this that just has the 2 holes for the front and hope that that's good enough. Maybe that's going to be my approach. But anyway, I'm going to go off and do some research on my own before we continue and try to figure out whether I have to design something or whether something already exists for mounting this thing onto a Dragon Burner tool head. All right, so I've done a little looking around online and I have a plan for how we're going to mount this Nebula extruder onto my Dragon Burner. So I wanted to show you, first of all, if you go over to Big Tree Tech's GitHub repositories, there is a fairly new repository for the Nebula there. I will, as with all things that I include in this video, I'll leave links to what I ended up using and to resources like this down in the description. So if you're following along, you can go find them there. So anyway, at this GitHub repository, there is a link as well to their wiki that shows all kinds of information about the Nebula extruder, dimensions, some pinouts and things like that down here as well. There is an expanded view of what it looks like inside, so you can see kind of how the planetary gear system works and all of that as well. So all of that is useful. I took a look at all of that, but what I wanted to show you here on the GitHub repository is they do have some 3D models. And the closest thing to the Dragon Burner that I'm using is, they have some stuff for a stealth burner. And so there are STLs here for if you're building or putting this into an existing stealth burner. You can see here that they have, basically this version of the stealth burner top cowl, the extruder part of it, that has the correct 4 mounting holes for the Nebula to go in there. So that, is not useful for me for this specific project, but they do have that, and they also have some mounting options for Rat Rig and a few others, but nothing for Dragon Burner. And so what I ended up doing, they do have somewhere here a nice reference CAD model, a step file of the Nebula itself. And so what I've done is I went and loaded that into my 3D modeling app here. I'm using Plasticity. And so we can see that they have, a fairly detailed, good mock-up of what this looks like. And so what I did is I loaded that, and I also loaded the step file that is over on the official Dragon Burner repo for the Dragon Burner. And you can see here I've taken these top parts that fit right onto here that are the different mounts for different types of extruders, and I've kind of exploded them out all around the main body here, because what I was looking for was something that was a good baseline that I could then modify to fit the 4-hole pattern here on the bottom of the Nebula. And what I ended up finding kind of by accident is this one right here, which is the mounting plate for the LGX Lite extruder. I was going to use that as my default kind of starting point because these side holes here where you put the screws down through the sides seemed like they were wide enough to be around the outsides of this thing. So anyway, I grabbed this thing and I actually copied it and I put it down here below the extruder, and we can see that somewhere here if I turn this on. And what I happened to find that I was not expecting is that the two holes that were already here for screws and the filament path line up perfectly. And so it looks like, I don't know if they did this on purpose or not, but this Nebula extruder has the spacing, the screw and filament path spacing of the LGX Lite extruder, at least for those front two screw holes. And you can see here that the back ones are here and here, and they wouldn't be used in this configuration. But I decided that this is probably going to work okay. I think this is going to hold the extruder on in a nice solid way, and we're just not going to use these back two screw holes. So it ended up that I didn't have to design anything of my own for this. We're just going to use this LGX Lite extruder mounting solution for the Dragon burner. And then of course, this piece that goes below it, which this is the version that's made for the Revo Voron, which is the hot end I'm using on my Dragon burner. I'm going to have to print a new version of this piece as well because my current one won't have the right screw holes for these screws here to go down into the thing. So I'm going to have to print both of these parts, and we'll have to replace those in my Dragon burner as we build this out. And then the other thing that I wanted to try to do was to come up with a mounting solution for the toolhead PCB that I have. It's the Pico Bilical, the LDO Pico Bilical kit is what came with my Voron 0.2 kit. That's what the toolhead PCB is. And so there wasn't anything that I could find that perfectly lined up with that, but I did find something that was close that I thought was good. So over here on printables, there's this LGX Lite to the Pico Bilical toolhead PCB adapter. It looks like this. It's close to what I need, but the spacing of some of these holes wasn't perfect to line up. So again, what I've done is I downloaded the step file that creator provided there, and I've gone ahead and put the two spacers here, lined them up with where this motor sits. This is actually rotated 90 degrees from most extruder motors. Usually the spacers would be up here and down in the other corner down there. And then I've modified that PCB mount. So it sits here, it lines up with these holes correctly, and then we'll put two heat set inserts in here to mount our PCB. And I've also verified that if we turn on the X carriage piece, so this is the Dragon burner piece that attaches the entire tool head down to the X rail, these two holes here as well line up with the holes there to add some additional stability when we screw this all together. So what I'm going to do is go and print these pieces here. If I hide the Nebula mockup, so these pieces that you see right here are the ones that I need to print, and then that additional one, this one here, that goes down below that. So I'm going to get those sent over to my printer. And like I said, I'll link to these specific parts down below. So if you're building this exact same configuration that I'm building, you can follow along and grab those. And these ones here will be a new build that make that I put up on printables because it is a slightly remixed version of the existing PCB mount that I found. So I'll put that up on printables. I'll link to it, and I'll link to the others as well, like I said. And I will go and send these over to my big Voron printer, get them printed out, and we'll go ahead and get the Nebula extruder installed on the tool head. Okay, so I've got our new parts printed, and I've started disassembling the old Dragon burner here. So down along the bottom row here are all the new parts. I've gone ahead and already put heat set inserts into all the spots where they need them. And then these are the old parts they're replacing. I've already taken off the old orbiter extruder here. This obviously is our new Nebula that we're putting in place of it. We've got the mounting plate for that, and then these are for the toolhead PCB that goes on the back, which right now is just hanging loose here. But before I continue, I need to go ahead and I'm going to try to not disconnect any of these wires. I'm just going to cut the little cable ties that are kind of holding them down, and I've got to take this piece out here, remove the extruder, or I mean the hot end, off of this, and then replace it with this piece here, because again, the only difference is the width. If I hold this up here, maybe you can see like these two holes on the outside of this piece are slightly more outside, toward the outside edges of the extruder, and those are to line up with the holes here in this piece when we go to screw the extruder down and secure it on there. So I've got to replace this part. That's probably going to be the most tricky bit of this whole thing, just because I've got to deal with these wires and then reroute them. So I'm going to go ahead and do that, and I believe that I'm going to have to cut a longer piece of this PTFE tubing as well, because if I place this down here and then I put the extruder on top here, I can tell that this is not going all the way up into the the filament path here as far as it should go. So there's probably, I don't know, I would say another, maybe, it's not a ton, maybe 2 or 3 millimeters. If I push this all the way down there like that, and then I try to push this down, yeah, there's a little bit of additional length that I need for that. So I'm going to cut a new piece of this tube as well. All right, so that looks good. Yeah, I'm happy with that. And so now let's see if we can go ahead and get this mounted right there. Before we do that, there is an M3 nut that has to slide down into this little slot so that we can screw something in from the back later on. And then I think, given just kind of holding things up to this, that these M3x8 socket head screws are going to be the right size to fit in here and be nice and flush with the part here. All right, so tighten those down nice and tight. And yeah, that's nice and solid. Like I'm not concerned about not using these back to screw attachment spots on the Nebula. I think we'll be good. And we do have access on the sides of it to these screws that will go top down. Let's just make sure. I've got, let's see, this one's probably too long, but we can at least, yeah, that fits there. No problem with the clearance on the sides of the extruder. So we're good. Cool. And then this longer piece of PTFE tubing that I just cut should fit in there and all the way down into here. Let's actually do this end first and then see whether we need to trim any off the top. I cut that a little bit long on purpose. Yeah, so it is just ever so slightly too long still. The other thing I did, I don't know if I showed the footage of this or not in the, or if I will show the footage in the edit of working on this, but I did kind of taper the top end of this with my hobby knife. I tend to like to do that on the side that the filament's entering from the extruder, just because it makes it, it helps it to feed into the path just a little bit better. So we'll cut off the other end that doesn't have that taper. And we'll check this out again. Yep, that is perfect now. Cool. So I guess we can go ahead and screw this down. I think that these, which are M3x12s, are going to be the right length to get down into there. Actually, the heat set inserts are further down than I thought, so let me grab something bigger. M3x16s, maybe? Yes, that seems good. All right, so we'll go 16s down through here and into there. Nice and snug, but not over tight. Yeah, that's looking good. Excellent. Nice and solid. Not going to have any issues. Cool. Now, maybe I should have done this before this moment, but I did discover, or I thought about as I was designing these little standoffs here that go on the back. So they mount here on the back of the motor to put our toolhead PCB in place. The Nebula Extruder came, usually there's like a bit of extra screw coming out the back of the motor with most extruders, and then you can just screw this on to there. The screws that came with this one are very close. You know, they don't protrude out the back there very far, and so there is no way for this to bite onto there. And so what I'm gonna have to do is pop this off and replace these two screws. So this goes all the way through, I believe. Let's remove one and see. Yeah, it feels like actually that only attaches right there on the motor mount. Yeah, otherwise it's just loose all the way through. So this screw is all the way through and into there. I'm gonna need longer ones of those screws. So I went to my local hardware store because I didn't have, these are M3 screws, but I didn't have the correct length with this kind of flathead design. I only had, you know, socket head screws like this, and that would get in the way of putting the faceplate back on. So I went and found these guys here, and they should be what we need. So these are M3 by 35s, I believe. And if I put this all the way in there, it's going to have some extra amount sticking out the back there. So now that should give me enough extra to be able to attach these standoffs on there. So I'm going to go ahead and remove, wrong kind of screwdriver, remove this one as well. Probably worth noting, if you're going to do this, you probably want to just remove these one at a time and then put the other, you know, put the replacement in place, because I have a feeling that if you remove both of these screws at the same time, there's a good chance that the entire extruder is just going to come apart this way. So if you're doing this, be careful. And so now I should be able to place this on here, screw those two things in. That looks good. And then we've got two more screws that we can put in here to hold the PCB in place. Again, I'm just using the same ones that came out when I disassembled the old version of the tool head. Very nice. So this is our extruder motor coming out of the new Nebula there, and it can just plug in right here. As I said, everything else I did not unplug, and so everything else is still just as it was. And I can put two zip ties back down into here to hold those wires in place, and then we should be good to go. Hey there, welcome back to my very messy desk. I'm trying to clean things up here so I can give you guys a shot before I close this thing back up, just to show you kind of how it turned out. So what I did is, up here at the top of the extruder, there's this 5-wire connector that connects up in here for those extra functions that the extruder has. So I went ahead and plugged that cable in. I'm gonna run that cable through this white umbilical that I have here. I found the white electrical tape that I used went to wrap the ends of this umbilical back then when I first put this thing together. So I'm gonna go ahead and unwrap that and run this through there. And then it comes down through the little plate here at the top of the PIQU umbilical board. And what I did down here at the other end, if you just ignore all of the extra wire mess for a minute, 3 of these wires were already broken out into a 3-pin connector. So this is red and black, which is our 5-volt and ground. And then the yellow wire is the control wire for the LEDs. The PIQU umbilical board, which is up underneath this piece of plastic here, maybe if I tip it, you can kind of see that right there. That actually has a 3-pin connector over here for a that's specifically like labeled for LED control. And so I went ahead and just plugged that in there, hooked up to the correct GPIO. I think it was GPIO 1, I believe, on the PIQU umbilical. You can find the pinout for that. I'll leave a link again down in the description of the video to the PIQU umbilical board's pinout. Anyway, so that just worked once I set that up in my Clipper config as a LED light. And then what I did is I went ahead and pulled out the blue wire, this one here, which is the wire for the little macro button on the top of the extruder. And I ran it over here to the center pin of a 3-pin connector that connects over here to the second LED controller that this picobellical host board provides. And so all I'm doing here is I wired up that GPIO, which is GPIO 7, in the Clipper config to that macro button. And we'll see in a minute that that also works. And then I took the green wire, which is down here, and I went ahead and put that into the first pin of a 3-pin connector over here and plug that in where my old filament sensor used to be. And so that's probably the right moment to tell you guys about what I've changed here as well with kind of the layout of the printer. So if you're unfamiliar with the V0, the default design, at least for this revision of the V0, is that the filament comes in through the foot. So there was actually, there's a hole right here in this side of the foot where the filament path came in, and then this PTFE tube that I'm holding here ran from inside of the foot kind of up through the back of the electronics compartment here and then up to the tool head. And I always thought that was kind of weird. The reason that they did that is because the filament sensor, there was space for it down here in the foot. So this used to have a filament sensor in it. And you can also see I had a special mod here. I don't know if you can see there's a little button right here that had a clicky button that I was using to press to do load and unload a filament as well. So I think you can find a previous video about this V0 on this channel probably. You'll see information about that if you're curious about it. I'll try to remember to link that up in the corner right now as I talk about it. Anyway, I'm disabling all of that. Like, I don't need this filament sensor anymore, and I don't need this button because those things are functions that are provided now by the Nebula tool extruder up here on our tool head. So rather than running the filament in the bottom corner here and all the way up, what I've decided to do is I printed this piece here, which is a new back cover. It's going to sit right in here, and it replaces this nice kind of smoky acrylic piece that was here before. So it doesn't look as cool, but what it does is it provides just a filament insert right there. So what I'll be able to do is just stick a piece of PTFE tubing right up through that hole. I dropped it. I won't show you, I'll just do it later. Anyway, I can put PTFE tubing up through there and just run it straight from here into the chamber and right up to the tool head, and that seems a whole lot better. So what I'm going to be doing when I put this thing back together is putting this on there and changing my filament path just a little bit to shorten it up. All right, so I've got all the wires cleaned up and it's looking pretty good. And before I put this thing back over on the shelf and start doing some real test prints with it, I wanted to show you guys one more thing. I finally figured out a good use for these LED lights, I think. So I'm going to show you that, and we're going to do some testing of the unloading and loading of filament using the little button that's here up on the Nebula extruder. So I've got this shot. Hopefully you can see the computer in the background over here. My monitor shows the mainsail UI with the temperature graph and such. I've obviously been doing some testing already. You can see the nozzle temp has been going up and down. So what I've done with these lights, I already had this light down here underneath the heated bed, and I also have now the new lights up here on the extruder. And I was actually inspired by the faucet that we have in our kitchen, which has a little LED light on it that kind of fades from blue when the water's cold to red when the water's hot through different shades of purple in between. And so I've written some G code that actually does that here as well. So when we heat up the bed, this light here goes from blue to red, you know, bright red being whatever the temperature is that you set the bed to be, you know, whether that's like 60 or even 100, 110, whatever. So this light does that. And then these lights up here on the Nebula do the same thing for the hot end. And so I guess I can show you guys that as we test some loading of filament as well. So I'm using the filament sensor that's built in here, using some slightly modified versions of the G-code macros that came with the Nebula in that GitHub repository that they provided, and I've changed them a little bit. But the idea is as soon as this thing senses the filament in the sensor here, it will go ahead and suck the filament in a little bit, then it will heat the nozzle up, and then it will load the filament the rest of the way. So here we go. I put that there, and immediately it did grab it. And then we can see, hopefully over here on the graph, that the nozzle's starting to heat up. And you can also watch as this fades from blue through different shades of purple to bright red. I will probably speed up this footage just a little bit so you don't have to sit here for, 30 seconds or however long it is for this to heat all the way up, and then it'll go ahead and finish loading the filament and purge. So let's watch that happen. And there it goes. It's pulled the filament the rest of the way in to the hot end, and now it's extruding to do a little bit of a color purge. Now, I believe that this filament is the same one that I was just testing with, so the color's not changing on the little extra bit that we've got coming out of the extruder here. Actually, and while I'm remembering, every single time I show this printer on a video, everybody always asks me, what's that dark red color that you used for the filament on this thing? That is the filament here I'm using for testing. It is an ABS made by Atomic Filaments, and it's called Dark Cherry Red. So there you go. It is a beautiful color. I really like it a lot. All right, so now that that is loaded, it's actually started cooling down again. You can see that over here, and these lights will now fade eventually all the way back to blue, but I'm not going to let them go that far. I'm going to go ahead and just push the little push button here for the unload, and when I do that, it will then go ahead and reheat the nozzle back up to the unload temperature, which currently I have set at 220, and as soon as it's got that reheated, it will go ahead and spit the filament out. So again, we'll fast forward through this bit as it goes so that we don't have to sit here and watch it the whole time. And there it went. And yeah, we got a pretty decent tip here. I could probably modify the speeds and temperatures of the macro just a little bit to get the filament tips just a little bit nicer, but that's pretty good. The other thing I wanted to test real quick here is whether I'm purging enough down through here when I load filament to correctly change a color. And so I've got a bit of white PLA here, and that's about the most drastic change we could get to go from that dark red to white. I guess black to white would be even more of a change, but this will be a good test. So I'll get this loaded and we'll see whether I'm purging enough down there. All right, there's our purge done. And looking at this, it is just a little bit pinkish still down up here at the end. So I could probably use to purge just a little bit more. I'm trying to minimize that as best I can. So yeah, I'll update this though and make it a little bit more of a purge. And then there's one other thing I wanted to test before I close this thing up. So I'm going to unload this. The other thing I wanted to test is some flexible filament. So I've got a strand of black TPU here. And I just want to make sure that the sensor detects this when we push it in, that it's not too soft for the sensor to grab, and then also that the extruder does a good job of grabbing it. I think it should be fine. Just looking at the torque on the extruder, and also the way that the filament path is very constrained. Actually, I could probably show you that. I don't know if you guys noticed earlier or not when we were looking at this thing, but there is like some molded plastic that comes all the way down right to these gears. And then same out of the gears. So it's a very constrained filament path, which is probably great for things like TPU because they have less chance of getting loose inside of the extruder and causing jamming problems. So here we go. I'm going to push this in. Yeah, it did just grab it right away, so that's great. And I'll go ahead and let this load and just make sure it looks okay. All right, and there we are. We've purged from the white PLA to the black TPU, and that looks pretty good. The TPU is a little stringy. Of course, if I waited a bit for that to cool down, it would have been less stringy pulling it off of the nozzle. But yeah, that's looking good. All right, so yeah, I'm happy with the load unload performance of the extruder. I really like this idea with the LEDs and indicating the heat. You can actually see the bed one just turned off actually from blue. I had been playing with it earlier. And it cooled down. It uses the chamber temperature because the pico umbilical back here does have a chamber temp sensor. So it uses the chamber temperature as kind of the floor. So whenever the extruder hits the same as the chamber temperature or the bed hits the same as the chamber temperature, those LEDs will turn off. And then as they start to heat up again, it'll turn back to blue and then heat back up to red. So anyway, I like that idea. If you have comments or questions about that, let me know down in the comments of this video. I don't want to look into all of the G-code right now. I think this video is probably plenty long enough without going through all of that, taking a deep dive into that. But if you're curious about it, you can either go look at the G-code, which I always have shared up on my GitHub, and that'll be linked in the description, or you can let me know, and I would be happy to do a video in the future looking more into the G code that drives all of that. So anyway, I'm going to unload this one more time, and then I'm going to close this all up and go get it set back over on the workbench, and we'll do some test prints with it just to make sure that everything's printing okay and that the extruder looks like it's performing well. All right, so I spent the day doing a couple test prints. I thought we'd finish out the video by just taking a quick look at a couple of them. So since I already had the 0.4 millimeter nozzle in the printer, it usually has a 0.25 millimeter nozzle, but for whatever reason, I had a 0.4 in there. I went ahead and just printed this Orca Slicer test cube, which comes with this little screw-in piece that you can use to test your filament tolerances, and that screws in there nice. The bottom layer looks pretty good. I had to do a little bit of Z-height calibration, you know, obviously because I had removed and put back the tool head. So anytime you do that on a printer like a V0 that doesn't have any kind of Z-height, you know, automatic Z-height calculation, you got to recalibrate that. So I did that. Otherwise, though, I would say that the quality of this looks pretty similar to what I would have seen with the LDO orbiter extruder that we replaced on that printer. So nothing's really changed from that standpoint, and I didn't expect that it would. Yeah, everything looks good as far as that goes. And so I've just taken off of the printer this piece here, which is swapped back to the 0.25 millimeter nozzle, and I printed out one part of a Gundam wing bust model. So like if I pull this in view here, this thing was printed on my resin printer. I've never actually finished painting it and gluing it together, so it's a bit flimsy. I have to be careful when I move it around. But this little sort of wing ear part here, if we pull this off, I think it's stuck down with some putty. But this piece here is what I sent to the printer. And of course, this was printed in resin, so it's going to definitely look better, but let's take the supports off of this. I can already see there's some stringing here. I don't think that's the extruder's fault. I think that's because I'm using a roll of PLA that's been sitting out in the open in my very humid studio for like 6 months or so. So the filament definitely needed to be dried. And that particular roll was not in one of my fancy dry boxes that I build, and so it was a little bit wet. Usually PLA, you know, will last okay without picking up too much humidity. But we'll go ahead and pull that off, and that looks pretty good. So just, you know, looking at this and comparing with the resin print, it's actually not too bad. You know, we're getting most of the detail, the little panel lines and things in here. Again, the stringing here between those two parts is because of the filament, the moisture in the filament, I'm pretty sure. But yeah, dimensionally looks good. Down here where the supports were, it could use a little bit of cleaning up, of course. But other than that, I'm fairly pleased with how this works. And again, this is very similar to what I would have seen with the other extruder. So in conclusion, kind of, I guess I would say, I have not really noticed, you know, much of a difference in the printing that the printer does. I would say that this new Nebula extruder for me is roughly equivalent to the Orbiter 2 that I replaced it with, or that I had on there before. I would imagine that if you were doing something maybe different from my setup, maybe if you're doing like something with a high flow nozzle and you needed that extra torque that this extruder provides, or something like that, that you might notice a difference. For me, printing slowly on with a very small nozzle, which is what I do with this printer to try to print detailed parts like you see here, there's not much of a noticeable difference really at all in the final print quality. However, the things that the new extruder added as far as extra features, most especially the filament sensor built into the extruder and the little button on top that I can program for doing filament loads and unloads, that for me, just from a quality of life point of view, being able to load and unload filaments really quickly, especially on that small printer, because I don't have any type of a screen with control or anything like that on it. It was just, I was always having to do it from the web UI. So now being able to walk over to the printer, hit a button to unload filament, and then just put new filament in and it loads in, that is really, really convenient. And so I'm happy to have done the upgrade for that reason alone. And then I was able to do the cool thing with the LEDs that change color to indicate the temperatures of the hot end and the bed as well. And so that was fun too. So I would say overall, I'm happy with the upgrade. You know, the print quality is about the same. All those other cool little extra features that I've added are really good, and it's going to make using the printer more enjoyable going forward. So I think that's it. Those are my thoughts on the Nebula Extruder, and you know, more importantly, I think just on the upgrade that it enabled me to do with my little Voron V0. If you have questions or comments, of course, leave them below. If you want me to dig deeper into anything that we've covered, because I know it's been a long video and we've talked about a lot of stuff, leave those below too. Or you can jump over to my Discord and we can talk about them there. I'll leave a link to the Discord down in the description of this video as well. And with that, I will say, I hope you guys have a good day, and I'll see you next time.